Systems of equations in 3 variables, solving by Gaussian elimination. A matrix is an array of numbers. It's another way to represent equations without using variables. Write the system of equation below into an augmented matrix. Augmented just means we're including the number after the equal sign. So in order to do this, the first column is going to be the x coefficient, so the numbers in front of x. The second column is the y coefficients, the number in front of y. And the last column is going to be the number after the equal sign. Sometimes we use a line to represent the equal sign, like this. So filling in this one, we look at the number in front of x, so that's 3 and -5, in front of y, 2 and 4, and after the equal sign, 10 and 20. So if we were looking up here and we were doing the opposite, we know that this is x, this is y, and this is equal to. So we have 2x plus 4y equals -8, and 1x plus 0y equals 6. Well, technically, we don't want to write it like this, so this would just be x equals 6, because we don't need to write 0y. So in these next examples, we're just going to take our system of equations and put it into a matrix. So notice now we have z, so that means the first column is x, the second one is y, the third one is z, and the fourth one is after the equal sign. So for this one, we have 4, -4, 4, -4. Then we have 4, 1, -2, 5. And then -3, -4, -4, -16. For this one, notice we only have x and y. Since we don't have z, we assume z is 0. So this is 5, 8, 0, 25. Same thing here, -2, 0, 3, 16. And then notice this is out of order. So we need to do x first. So -5, then y, 17, then z, 8, then 22. And then again, this one is also out of order, so I'm going to have to move this z over. And we would have 3, 2, -3, -4. And then these are out of order, so I have 2, -4, 8, 2. And then I have 3, -4, 5, 15. Solving a system using a matrix. We need to manipulate the matrix to make it an upper triangle matrix. This means that the bottom triangles are zeros. There's a diagonals of 1. Okay. And the rest are numbers. So what these ones represent in each row is a different variable. So this is x, this is y, and this is z. Doing this is called row echelon form. To eliminate these elements, you're allowed to do the following operations. You can add or subtract 2 rows. Honestly, I just want you to add. Okay, it gets more confusing when you try to subtract. You can swap 2 rows. This is rare. You're rarely going to do this. Okay, and then you can multiply a row by any number, but not 0. Okay, these are your main ones. You're going to add rows together and you're going to multiply a row by something. So let's look at the first example. First thing is I'm going to fill in my matrix. So I have -1, -5, -5, 2, 4, -5, 4, 19, 1, 5, -1, -20. Our goal here is to get this lower triangle of zeros. And in order to do that, the very first step we should follow is try to make this one 0 first. Okay? Then from there, I'll show you the order. So in order to make this one 0, this is row 1, row 2, and row 3, we have to look at the other rows. Well, in the first row, I see a -1. And if I was to add the first row to the third row, -1 and 1 is 0, and that would achieve my 0 in that spot. So that's what I'm going to do. So step 1, I'm going to get my new row 3 because I want my 0 there. And in order to do that, I'm going to do row 1 plus row 3, which means row 1 and row 2 don't change because I'm only getting a new row 3. Okay, so I'm going to rewrite -1, 4, -5, -5, -5, 4, 2, 19. I'm going to add row 1 to row 3. Okay, here's row 1, here's row 3. -1 and 1 is 0. Okay, -5 and 5 is 0. That's okay. Okay, that's even better because eventually we'll need that 0. -5 and -1 is -6. And 2 and -20 is -18. Okay. Now notice, again, we're trying to get that lower triangle. And when we did that, not only did we start off with this one and got that one 0, we also got another 0 here, which means we only need to turn this 4 into a 0. Okay. And in order to do that, we are going to look at row 1 because it has a -1 and row 2 because it has a 4. And so in order to cancel this, we would have to multiply row 1 by something and then add it to row 2. So step 2. We're going to multiply row 1 by 4. So 4 times row 1, we're going to add that to row 2, and that's going to give us our new row 2, which means when I write my matrix, row 1 and row 3 stay the same. So -1, 0, -5, 0, -5, -6, 2, -18. Okay. And now I'm going to do this math here. So 4 times row 1. So that's -1 times 4, which is -4. -4 plus 4 is 0. Okay. 4 times -5 is -20. -20 plus -5 is -25. -5 times 4 is -20. -20 plus 4 is -16. 4 times 2 is 8. 8 plus 19 is 27. Okay. Now look what we just achieved. We achieved a lower triangle of zeros. That means we no longer have to look at our matrix. We can now turn this into an equation. Well, before I do that, I can look at every single row and I can see if I can reduce any by taking out a GCF. So this is the first row. I'm looking, is there a GCF between -1, -5, and 2? Nope, there's not one in that one. Then I check this one. Is there a GCF for -25, -16, and 27? Nope. Then I look at this one. Is there a GCF for -6 and -18? Yes, -6. So if I divide both of these by -6, I get 1 and 3. Okay, which means I now have, right here, this tells me that Z is equal to 3. Okay. Then I look at the equation above. Then I'm looking at this. This tells me -25y minus 16z is equal to 27. And then lastly, up here, this tells me -x minus 5y minus 5z is equal to 2. Okay. Once I have all these equations, and notice how I started from the bottom and then I made my way to the top, I can now substitute everything in. Because z equals to 3 means I can plug that 3 into here and solve y. And once I have y, I can plug it in here and z into here and I'll have x. So starting with the one I highlighted in green, so negative 25y minus 16 times 3 is equal to 27. Okay. So on my calculator, 16 times 3 is 48, so negative 25y minus 48 is equal to 27. I'm going to add 48 to the other side, and so this is negative 25y is equal to 75, which means y is equal to negative 3. Then I plug in 3 and negative 3 to find x. So negative x minus 5 times negative 3 minus 5 times positive 3 is equal to 2. Negative x plus 15 minus 15 equals 2. Negative x equals 2, so x is equal to negative 2, which gives me the answer x comma y comma z is equal to negative 2, negative 3, 3. This is my answer. Okay, next one. First step, turn this into a matrix. So I have 1, negative 1, 1, 2. Then I have 2, negative 3, 5, negative 3, negative 1, 6, 1, negative 1. Remember, my goal is to turn this into a lower triangle of zeros, starting off with this one being my first 0. So my step 1 is I'm going to look at the other 2 rows and see if there's anything, if I add it to it, will it cancel? Well, row 1 has 1, and row 3 has a negative 1. If I add them together, they'll cancel. So I do row 1 plus row 3 equals new row 3. Okay. Which means row 1 and 2 don't change, so I'm going to rewrite those. And then adding those 2 rows will give me my new row 3. So 1 and negative 1 is 0. 1 and 6, or sorry, negative 1 and 6 is 5. 1 and 1 is 2. And 2 and negative 1 is 1. Okay, I got my first 0. Now I'm going to try to get my second 0, and that's always going to be the one above it. Okay, again, I am looking at the other rows. Is there anything I can multiply another row by so when I add it, they cancel out? Well, my step 2 is that I can take row 1 and multiply it by negative 2. So negative 2 row 1, add it to row 2, and that will give me my new row 2. Because if I multiply this by negative 2, that will give me negative 2, and negative 2 plus 2 is 0. So that means row 1 and row 3 don't change. So this is 1, negative 1, 1, 2, 0, 5, 2, 1. Okay. Then I have 1 times negative 2, which is negative 2, plus 2, which is 0. Negative 1 times negative 2, which is 2. 2 plus negative 3 is negative 1. Negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. 2 times negative 2 is negative 4. Negative 4 plus negative 3 is negative 7. Okay, I now got my 2 zeros. I need to get my last 0, and that is right here. Okay, once you're at this step, you're always going to do something with the row above it. Okay, again, you're always going to use row 2. Okay, row 1, row 2, row 3. So step 3, I'm going to use row 2. Well, row 2 has a negative 1, and I want to cancel out a 5, so I'm going to multiply row 2 by 5. So 5 times row 2 plus row 3 is going to give me my new row 3. Okay, which means Row 1 and row 2 do not change. So 1, 0, negative 1, negative 1, 1, 3, 2, negative 7. Okay. So starting off, we have 5 times row 2. 5 times 0 is 0. 0 plus 0 is 0. Okay, next. Negative 1 times 5 is negative 5. Negative 5 plus 5 is 0. Okay. 5 times 3 is 15. 15 plus 2 is 17. Okay. 5 times negative 7 is negative 35. Negative 35 plus 1 is negative 34. Okay. I now got my lower triangle. So now from here, I can take this, okay, and I know that the first column is X, the second one is Y, and the last one is Z. So I can look and first see, can I take a GCF from each of the rows? The only row I can do that from is the third row, row 3, and I can take out a GCF of 17. So 17 divided by 17 is 1. Negative 34 divided by 17 is negative 2, which means I have Z is equal to negative 2. Okay, that's my very first one here. Then looking at my next one right here, this tells me that negative Y plus 3Z is equal to negative 7. Okay. Well, I know that Z is negative 2, so negative Y plus 3 times negative 2 is equal to negative 7. Negative Y minus 6 equals negative 7. Negative Y is equal to negative 1 because I add the 6 over. Y is equal to 1. Okay. And then in this last step right here, this tells me that X minus Y plus Z is equal to 2. Okay. I plug in what I already know. So X minus 1 plus negative 2 is equal to 2. So X minus 1 minus 2 equals 2. X minus 3 equals 2. X equals 5. So from here, I have the answer X, Y, Z is equal to 5, 1, and negative 2. That's my answer. Okay. Now what you should be doing is you should be trying number 1 and number 2. And let me give you the answers to those so you could use that to check your work. You just give me a couple seconds. Let me pull that up. Okay, so again, once you convert these to matrix and do the Gaussian elimination, you should get, for number 1, negative 2, 1, 3, and for number 2, 22, 6, 4. So look back up at the 2 example problems I just did, try them on your own, and see if you get this answer.